Welcome to Study Loop.
All right, we've got a question here that gives us the limit as x approaches infinity for e of x over x to the n, and we want to prove that this is true for all positive integers of n. Okay, first of all, if we know that we have all positive integers of n, then this will be infinity at the bottom, and then e to the infinity would also go to infinity, so we could say that we would get an intermediate type form of the type infinity over infinity. So we can apply L'Hopital's rule, and that would be the limit as x approaches infinity, e to the x to the n is equal to the same thing as the limit as x approaches infinity for the d dx, x over the d of x to the n, and that comes out to be the limit as x approaches infinity for e of x, now n, x to the n. Okay, and if we do that, we would get an infinity over infinity. All right, once again, that is the intermediate form. So what we're going to do is we're going to apply the L'Hopital rule another time, and we will keep, and if we keep doing it, we get to the point where we realize that our denominator is reaching infinity faster, and we would realize that our denominator, our limit will stay in indeterminate form until the degree of x in the denominator becomes 0, right? So it'll go on forever. So for example, if you take the L'Hopital of this, you'll get limit as x approaches infinity with a d dx of e to the x over d dx n x to the n. That should have been n there. Okay, and that comes out to be limit x to infinity to the x, n multiplied by n minus 1, e to the n minus 2. Okay, and we're still going to be left with an infinity over infinity. All right, now we're going to use what's called applying the L'Hopital's rule now n times. And if we do that, then we would get the limit as x approaches infinity for e to the x over n factorial. Okay, if we do that, then we have 1 factorial, 1 over n factorial e to the infinity, and that'll be equal to infinity. Okay, and then here we can see that the exponential function approaches infinity faster than any power of x. All right, and we can prove that this function here is true for all positive values of n. All right, well, I hope that clarifies the question. Thank you so much for watching.